Okay, this is a continuation of the notes that we were taking the other day. It's families of functions part two. If you remember on the previous day, we did four different families of functions, which was a linear function, absolute value function, a quadratic function, and I forgot the last one. But it'll come. Oh, exponential function. Sorry. So yeah, those are the four functions that we did last time. Today we're going to do two more. We're going to be doing a constant function and a linear piecewise function. Okay. Let's go ahead and take a look at the first one. I want to talk about what it means to be a constant function. So I'm going to go ahead and highlight uh, this vocabulary word. For constant functions, we're going to have it of the standard form f of x equal to some kind of number. We don't know what that number is, but I just know it's going to be constantly the same number. Okay, so I'm going to say f of x is equal to a. So if you have f of x or y equal to just a number, then you know it's a constant function. How are we going to be able to identify this? Well, in this case, you're not going to have any variables in the equation part. That is to say, on this part of the equation sign, you're not going to see any variables. You're just going to see a number. So no variables, only a number. You're just going to see a number on the right-hand side. So some examples of that look like this. You're going to have something that looks like f of x equals to 3. Notice on the right side, it's just a number. Or y equals to 8. Notice on the right side, it's just a number. And that's it. So on our example, we have the example y equals 4. And just like last time, I'm going to start plugging in my x's into this equation and see what I get. When I plug in x is negative 2, I look for my x's. There's nothing to plug in. All I know is the answer is 4. And so I'm going to go ahead and plot it, negative 2 comma 4, put a dot. Next one, I'm going to try x is negative 1. I'm going to take my x, anywhere I see an x, I'm going to replace it with a negative 1. Well, there is no x. So again, the answer is just 4. So I'm going to plot it, negative 1 comma 4. And we'll do this one last time. If I take 0 and I plug it in, there's nothing to plug in. There's no x's there to replace with a 0, so the answer is just 4. And I think you already understand, like, hey, these all are going to be 4, which means I get to plot 0 comma 4, 1 comma 4, and 2 comma 4, which means I'm ending up with a straight horizontal line that looks like this. Guys, I want you to notice that when we do this, y equals 4. Look at all these points. I got negative 2 comma 4 where the y is 4. Negative 1 comma 4 where the y is 4. 0 comma 4 where the y is 4. In each one of these cases, y is equal to 4. In each one of these cases, negative 2 comma 4, negative 1 comma 4, 0 comma 4, 1 comma 4, 2 comma 4. I don't know what your x value is, but I do know that the y value has to be 4. Okay? So that's one of the things that all of those things share in common. So now that we know what the graph looks like, let's go ahead and start talking about some of the characteristics. A constant function has the same output, even with different inputs. So let's go ahead and write that. The graph is a horizontal line passing through the given value of y. And because that describes its shape, then this is the one I'm going to highlight in yellow. I know that these kind of constant functions have horizontal lines, which is exactly what I have here. And I just want you to note that it passes through right here where y is equal to 4. So if your example would have said y equals negative 1, you would have gotten the exact same graph. It's just that on your y-axis, here's negative 1. You would have gotten a graph that looks like that, okay? And then the slope of the constant function is 0. There's a reason for that. Remember that this is a line, right? And I know all lines look like this. Y equals mx plus b. But here, it's not going up anywhere. So when you do your rise over run, it's going to be 0 over something, which means your slope is going to be 0. And if your slope is 0, that means you have 0x plus b. Well, 0x is nothing. That's 0 plus b, which is just b. So you're going to get something that looks like y equals b, which is exactly what we got, guys. We got y equals 4, right? Y equals some kind of number. And that generates a horizontal line. I think that's it for the horizontal lines. Just know it's going to be like y equals a number. All right. Let's take a look at the next one. The next one is a lot more complicated. And sorry, I don't know why it's kind of blocked off like that. It doesn't look like that on my screen. Hopefully it'll, oh, there you go. Kind of fix itself. Sorry about that. All right. So last one we're going to do is a piecewise function. Piecewise functions. You can identify a piecewise function because it's going to look like f of x equals something on the top and then maybe something else on the bottom. There are different pieces to this function, which is why we call it a piecewise function. And you'll see it even more on the graph, okay? How do I know if it's a piecewise function? Well, the function is going to have more than one linear function. So there's going to be more than one piece to it. Like I said, we have the top piece, we have the bottom piece. I know that looks really complicated, and to some extent, it is a little bit complicated. But I'm going to try to show you kind of better ways on how to do it. So right here, they have an example of what that looks like. Notice that there's a piece on the top, piece on the bottom. That's how we know it's a piecewise function. This is going to tell us we are going to plug it into this equation whenever my x's are negative 2 is less than x or is less than 0. So whenever my x's are between negative 2 and 0, I'm going to be using this top function, okay? And whenever my x's are between 0 and 5, I'm going to be using the bottom function. So let's start off with the first number here. Hey, actually for this one, we're going to do every single one because it is a little bit complicated. So I'm going to plug it into every single one instead of skipping like I did on the last couple ones, okay? So let's see. My x is negative 2. Whenever you're dealing with a piecewise function, you got to figure out, okay, that negative 2, am I going to plug it into the top or I'm going to plug it into the bottom? And that all depends on which set you're in according to the rules on the right-hand side. So negative 2, is that negative 2 less than or equal to x less than or equal to 0? Or is negative 2 somewhere between 0 and 5? Negative 2 belongs to the set on the top. It does not belong between on the set on the bottom. Remember, these are only the numbers between 0 and 5. These are the numbers between negative 2 and 0. So negative 2, I'm going to highlight this with a different color. Negative 2 belongs to this set on the top, which means the negative 2 I'm going to plug in right here. So what I end up with is negative 4 times negative 2 minus 1. Negative 4 times negative 2, that's an 8 minus 1, and 8 minus 1 is 7. So when I plugged in a negative 2, the answer I got was 7. Because negative 2 belongs to this set, and there's an equal sign on the negative 2, that means negative 2 is part of my set. So when I do negative 2, I get to fill in the circle at 7. All right, let's try it again because I know that was not easy. Negative 1, I don't know whether to plug it into the top or to plug it into the bottom. I need to figure out what set does it belong to. Does it belong to the numbers between negative 2 and 0? Or does it belong to the numbers between 0 and 5? Well, negative 1 belongs to this set right here. So negative 1 is going to go to the top. I'm going to go ahead and highlight that on orange, which means the negative 1 I get to plug into the top right here. That's going to be negative 4 times negative 1 minus 1. That's a positive 4 minus 1, which is 3. Because it's still part of the same set, I'm going to be connecting this. So negative 2, negative 1, negative 1 comma 3. I'm going to put a dot right here. All right, guys, this next one is going to be the super complicated one. So here we go. I'm going to look at the number 0. I'm going to say, hey, the 0, does it belong to the set on the top, the numbers between negative 2 and 0? Or does it belong to the set on the bottom, the numbers between 0 and 5? Well, 0 is kind of shared between the two, right? Like I know it ends in 0 here and it starts in 0 here. So it's kind of a mix of both. I say kind of, not entirely, but kind of, okay? So I'm going to shade it in orange and in another color. What do I mean by that? I mean, I'm going to shade half of it orange and I'm going to shade half of it pink because pink is going to be this set down here. I'm actually going to plug it in for both, and then you're going to see what I'm going to do with it in a little bit. Okay, so let me plug it into both. -4 times 0 minus 1. That's 0 minus 1, which is a -1. Okay, so this is going to be a -1 for the orange side. I'm going to put a little squiggly line right here. So when I plot 0, -1, 0, -1, that would be the dot here. However, if I were to draw this, let me just make sure I did that right. Yep, it looks good. Okay. Hey, remember what we said about sets? The 0. Can it be really 0 here? No, because it says it's not equal to 0. It's just less than. So this line is going to get close, 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 but it's actually not going to touch that dot. How do I show that get really close to this dot but don't get there? Well, we're going to erase what we just did. And instead of doing a closed circle, I'm going to do an open circle because, again, the 0, it gets really close to the set, but it's not exactly on the set because there's no equal sign here. So what you end up with on the left is you get a straight line that starts at -2 here, and it keeps going down, 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 and then it gets really, really, really close to this dot, but it doesn't actually touch it because, again, there's no equal sign here. All right, hey, I'm going to take, remember, we said 0 kind of belongs to both sets, kind of, sort of, right? So I already did the 0 for the top set, but I made sure that it was an open circle. Now I'm going to do the 0 for the bottom set because it's also part of this one. So we're going to go ahead and type in 2 times 0 minus 3. That's going to be a 0 minus 3, which is a -3. So for 0 on the pink set, that's 0, -3. 0, -3 is right here. I'm going to go ahead and plot it. But because 0 is kind of sort of part of both sets, I got to check. Okay, 0. Does it work for this top one? It does because there's an equal sign down there. That means this dot does work here. So I'm going to go ahead and fill it in. Okay. I know that 0 is that boundary point that kind of does the flip. Like, it's kind of weird because it kind of sort of belongs to both sets, even though it only really belongs to the pink one on the bottom. Okay. All right. Let's go ahead and move on to the next one. The next one should be a lot easier. I'm going to go ahead and plug in a 1. 1 does not belong to the set on the top. 1 is not between -2 and 0. 1 does belong to the numbers between 0 and 5. So I only plug in the 1 into the pink set. So I'm going to go ahead and write 2 times 1 minus 3. That's a 2 minus 3, which is a -1. 1 comma -1 would be right here. And then the last one I'm going to check is 2. 2 does not belong to the numbers between -2 and 0, but 2 does belong to these numbers. Therefore, I'm going to be using the bottom set. I'm going to go ahead and plug in the 2 there. I get 2 times 2 minus 3. That's a 4 minus 3. That's a 1. So when I plugged in the 2, sorry, that should have been in pink because I plugged it into the pink set. Whoop, 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 whoop. Couple mistakes there, sorry. When I plugged in the 2 into the pink set, the answer I got was a 1. So I'm going to go ahead and plot 2 comma 1, put a dot. Now normally I would say, oh, go ahead and put arrows on this, but we're not going to do that because, we're not going to do that because this set starts at 5. So I guess I should do it all the way up until 5. You see this 5 right here? So I'm going to keep extending this line over all the way. What's it doing? It's going up to right 1, up to right 1, up to right 1, up to right 1, up to right 1. And I'm going to stop it at the 5. Because again, your set says it needs to stop at 5. So take a look at that graph. That graph is crazy looking because, again, there's 2 parts to it, right? There's the first part when your x's are between -2 and 0. And then there's the second part when your x's are between 0 and 5. You know what I just realized? This dot I filled in, and 5 is not part of my set, right? Like you see that right there? There's no equal sign down there. That means this 5, get really, really close to it, but don't touch it. So I need to get rid of it. What's wrong with it? Well, it should, because 5 is not part of my set, it should be an open circle right there. I just noticed that right now when I did my notes the first time, I did it the wrong way. So I'm glad I kind of caught it right now. Okay, so that's why I have that open circle right there because again, there is no equal sign on the 5. So your graph stops right there. All right, let's go ahead and start describing this graph. It consists of 2 or more linear functions. So the shape of this graph, it's going to have like 2 different pieces to it. Since it's describing what my graph looks like, I'm going to go ahead and highlight this in yellow. 2 or more. That means, guys, it might be more than 2 pieces. Sometimes you're going to have like 3 pieces or 4 pieces or a heck of a lot more. It just depends, okay? But basically, there's more than one piece. The graph has 2 or more linear functions, constant functions, sorry. Straight lines. What am I doing? It has 2 or more straight lines. Because they're linear functions, they're pretty much saying the same thing. Each function has an interval. What that's saying is there's only a certain spot where that function works from. It only works from here to here, and then it does something else. Then it starts doing stuff from here to here. So it's broken down into pieces. But because it's a function, it still passes the vertical line test. You remember the vertical line test was you keep drawing vertical lines, and it should only touch your graph exactly once, or at most once. And remember that right here on this one, it's still only touching once because it's not touching at the top, but it is touching on the bottom, okay? All right, those are the notes for today. If you have any questions, feel free to ask.